So this is the solubility product. Solubility product means let us consider sparingly soluble salt. Sparingly means weakly soluble salt like the AgCl. So the AgCl will dissociate to Ag plus and Cl minus. As you know, the sparingly soluble salt maintain a dynamic equilibrium between the dissociated ions and undissociated molecules. So the AgCl and Ag plus and Cl minus are maintaining dynamic equilibrium. So to this dynamic equilibrium, according to law of chemical equilibrium, so the equilibrium constant Kc is equal to product of product concentration by the reactant concentration. As we know, for the law of chemical equilibrium, this is the equilibrium constant relationship. So at constant temperature, whatever the AgCl to be dissociated, it will be dissociated. The remaining AgCl will remain constant. Remaining AgCl will remain constant. So this is a constant and it is another constant. If we multiply the two constant, that become a new constant, and that is equal to Ag plus concentration into Cl minus concentration. This new constant is called as the Ksp. Ksp is equal to the Ag plus concentration into Cl minus concentration. Clear? The Ag plus concentration into Cl minus concentration. So this is called as the solubility product constant. This is called as solubility product constant. So for any type of sparingly soluble salt, solubility product constant is equal to the product of molar concentration of all ions produced by the sparingly soluble salt, and each raised to the power equal to the coefficient appear in the balanced chemical equation. As it is appeared 1 here, so it is 1 raised here. Okay. So next is the relationship between solubility and solubility product. So what is the difference between solubility and solubility product? Solubility means the amount of solute solubilizes in water. How much extent is solubilized? It may be the gram per liter, it may be the moles per liter. The solubility is represented by S. Suppose you will take the 10 gram. Out of the 10 gram, suppose 4 gram is solubilizes per liter of solution. So the solubility is 4 gram per liter. It can be converted to moles per liter also by dividing the molecular mass. Okay. The solubility means the amount of solute solubilizes per liter of solution. So this S may be the gram per liter, or S by M by dividing the molecular mass, it will be the mole per liter. So by dividing M is the molecular mass, by dividing the molecular mass, the gram per liter can convert it to moles per liter. Similarly, suppose it is X mole per liter, then X into M, that become gram per liter. Okay. But normally the moles per liter is the more convenient way to represent the solubility. Clear? So the solubility and a solubility product constant, to understand this relationship, let us consider a salt, maybe the sparingly soluble salt, that is the AXBY. If we consider the AXBY, how to dissociate? It will maintain also dynamic equilibrium, X moles of A plus Y and Y moles of B minus X. It will be plus Y and it will be minus X. It is the cross multiplication, that's the compound is formed, and it will ionizes, it will compound like this. Initially, when time t is equal to 0, If you take 1 mole, it will be 0 and 0. At equilibrium or after some time, after time t. So if it is S mole is solubilizes, then it will be XS and it will be YS, because it is X coefficient, it is Y coefficient. X coefficient and Y coefficient. That's why it is XS and a YS. Clear? So then so as we know, the KSP, the solubility product constant, is equal to the product of molar concentration of all ion A plus Y raised to the power coefficient X, B minus X raised to the power coefficient Y. Okay. So the KSP is equal to X to the power X, Y to the power Y, S to the power X plus Y. Clear? So the S to the power X plus Y, that will be equal to KSP to the power X to the power X, Y to the power Y. And S is equal to the KSP by X to the power X and Y to the power Y whole to the power 1 by X plus Y. Clear? So the different types of salts are there. AB type, we can take AgCl. This type of salt, here X is equal to 1, Y is equal to 1, and KSP is equal to 1 to the power 1, 1 to the power 1, S to the power 1 plus 1, that is equal to S square. Clear? It is AB2 types. Let us take the calcium fluoride or Na2S. So here X is equal to 1, Y is equal to 2, and KSP is equal to 2 to the power 2. It may be AB2 type or A2B type, same things. So that will be equal to 1 to the power 1, S to the power 2 plus 1, that is equal to 4SQ. So that is equal to KSP. Somebody can consider the magnesium hydroxide also under the same categories. Next is the AB3 types. So under this category, we can take the aluminum hydroxide, we can take the ferric hydroxide also. X is equal to 1, Y is equal to 3. KSP will be equal to 1 to the power 1, 3 to the power 3, S to the power 3 plus 1. So the KSP is equal to 27 S to the power 4. Correct? So this is the different relationship. Then you can take the AB fourth. X is equal to 1, Y is equal to 4. We can take the example of K fourth APCN whole 6. So this is also this category of salt. So the KSP is equal to 4 to the power 4, S to the power 4 plus 1, that is equal to 256 S to the power 5. One more salt we can take the A2B3. Under this category L2, SO4 whole 3, CA3PO4 whole 2, this type of salts come. So under this condition, the X is equal to 2, Y is equal to 3, S is equal to 3, X is equal to 2 and Y is equal to 3. So the KSP will be equal to 2 to the power 2, 3 to the power 3, S to the power 2 plus 3, and KSP is equal to 108, S to the power 5. So these are the varieties of salt we have discussed here, and accordingly whenever required we can get the relationship also. Okay. So the numerical problem what will be asked normally. So let us take KSP of AgCl is 1 into 10 to the power minus 8. Find solubility in gram per liter and moles per liter. So here we know the KSP for AgCl. KSP of AgCl is equal to S square. So the KSP value is given 1 into 10 to the power minus 8 is equal to S square. S is equal to 10 to the power minus 4 moles per liter. If you want to, initially what is coming, it is moles per liter. If you want to convert to the gram per liter, then you can, it is also possible. So the moles per liter, if you multiply the molecular mass, that is 2.5. Correct? 142.5 into 10 to the power minus 4 gram per liter. So this is the molecular mass of HgCl that we have multiplied here. 143 perhaps. Yes. So let us take another one example, a little bit harder problem we will solve. Let us take the solubility of calcium fluoride is 1.2 into 10 to the power minus 6 gram per liter. So find the Ksp here. For calcium fluoride, you know that is the 4sq will be the relationship. SQ is the relationship. So in the 4sq with the relationship, the S is given, but unfortunately this is given in the gram per liter. We can convert to the moles per liter. So in the gram per liter is given, then we can convert to the moles per liter by dividing their molecular mass. You know that we have already explained how to convert the gram per liter to mole per liter in other chapters. So this here we have mentioned the gram per liter can convert it to the moles per liter. So this way you can convert here. So the dividing the molecular mass, fluorine is 19, that is 38, and it is 40, that is 78. So that will be moles per liter. So this is the solubility. So then what is the solubility product? Then 4 into SQ. So that is 4 into 1.2 into 10 to the power minus 6 by 78 whole to the power 3. That is the answer for the Ksp. Then you can calculate how much it is coming. That is the solubility product of calcium fluoride. Okay. So how in the previous year IIT what the question asks. So the magnesium hydroxide Ksp of magnesium hydroxide is 4 into 10 to the power minus 8. 4 into 10 to the power minus 9. It is given like that. So find the pH of magnesium hydroxide solution. That is a very interesting question. Here the solubility product is given, but it is asking the pH of the solutions. So we have to interlink here. So we know for this problem the Ksp for the magnesium hydroxide will be 4sq. The Ksp is given 4 into 10 to the power minus 9 is equal to 4sq. So intentionally we have given 10 to the power minus 9 so that it will be cancelled. So the 4 will be cancelled. So the s to the power 3 is equal to 10 to the power minus 9 and s is equal to 10 to the power minus 3. So what will be the unit? The s is equal to 10 to the power minus 3 moles per liter. Are you getting my point? So this is the 10 to the power minus 3 moles per liter. That is the solubility. So the solubility is nothing but the molarity of the solutions. Okay. So you know this is given the OH minus concentration. OH minus concentration is equal to the molarity of the base into the acidity. You know that is acidity means the number of OH minus sign given by the base. So the OH minus sign concentration, so the OH minus concentration is equal to molarity into acidity. So here the molarity is given 10 to the power minus 3. And the acidity here, the magnesium hydroxide acidity is acidity is 2 here. So that means the OH minus concentration is 2 into 10 to the power minus 3. That is the OH minus concentration. So what will be the pOH here? You know the pOH. pOH is equal to negative logarithm of OH minus concentration. So that is equal to minus log 2 into 10 to the power minus 3 and that is equal to minus log 2 plus log 10 to the power minus 3. So that is equal to 3 minus log 2. 3 minus log 2 means 3 minus 0.3010. So that is 2.7. So the pOH is equal to 2.7 that we have find here. So what will be the pH? pH plus pOH is equal to 14. the pH is equal to the pOH 14 minus pOH. So the 14 minus 2.7, that will be equal to 11.3. You know the base, you see here the 14 pH is equal to the 14 minus pOH. You see here. So the 14 minus 2.7, that is equal to 11.2. So 11.2 means 11.3 means, so that is the basic solution. The pH is more than 7 means it is the basic solution that we have calculated. Sometimes the question, the reverse question may be given. Question number 3, question number 4, you see. Sometimes what is given, the pH of calcium hydroxide, or we can take the aluminum hydroxide, is equal to 11. Calculate the KSP. So that is another type of questions. So here the pH is given, you have to calculate the KSP. So how to solve it? pH means the H plus concentration is equal to 10 to the power minus pH. So that is equal to 10 to the power minus 11. So this is the H plus concentration, and OH minus concentration, obviously it will be 10 to the power minus 3. Okay. Or directly you can convert pH is 11, the pH is equal to 3, and OH minus concentration 10 to the power minus 3, whatever way you can adapt. So once you calculate the pOH, the OH minus concentration, though we know the OH minus concentration is equal to the molarity into acidity. As we know, the acidity of aluminum hydroxide is 3 here, 3 OH it can provide. Though it will be 10 to the power minus 3, and it is the molarity. So what about the molarity? Molarity you have to calculate. So the molarity, that is equal to 10 to the power minus 3 by 3. So that will be 0.33 into 10 to the power minus 3. Clear? So once we calculate the molarity, then the molarity of aluminum hydroxide is calculated. That is nothing but the solubility. So that indicate that is that is same as the solubility. So once we calculate the solubility, so then the KSP you can calculate. The KSP of aluminum hydroxide, as you know, last year we have calculated here. It is AB3 types. So it will be 27 to ds to the power 4. So that is equal to 27 into 10 to the power 27 s to the power 4. So 0.33 into 10 to the power minus 3, that is equal to 27 s to the power 4. So that means the s to the power 4 is equal to how much? 0.33 into 10 to the power minus 3 by 27. So it little bit of calculation that we can to the power 1 by 4, we can calculate to what the value is coming here.
1 by 3 now, 81 is.
So it is 0.33 is taken.
So the 1 by 3 now, the 3 into 27, 81 is.
Yeah. So it is 0.33 by 27, that is 1 by 81 into 10 to the power minus 3 whole to the power 1 by 4. That we can calculate, that is S is calculated. So our aim is to calculate the KSP. So we no need to calculate all these things. We have wrongly put it here. We have to rewrite again. So the KSP, that is equal to 27 into s to the power 4. So the 27 into 1 by 3, 27 into 1 by 3 s to the power, in place of s we can write 1 by 3 into 10 to the power minus 3 whole to the power 4. So then it will be the 27, it is 1 by 3 into 1 by 3 into 1 by 3 into 1 by 3 into 10 to the power minus 12. So the 3 will be cancelled. So that is only remaining is 1 by 3. 1 by 3 is equal to 0.33 into 10 to the power minus 12, and that is the answer. Okay. So this way you can calculate the reverse type of problem. Are you clear? Okay. So this is all about the solubility product. How to calculate the solve the problem. We will see the other materials. to calculate the problem related to the solubility product. So from this material, we will try to work out some problems from the solubility product related questions, and it is normally question asked in entrance examination, mostly from the solubility product. So is it given like this or not? So here you see the one more question that is given. The solubility of silver bromide is 5.0 into 10 to the power minus 3. The quantity of potassium bromide taken as 120 gram added to 0.05 solution of silver nitrate to start precipitating of AgBr. So that is one more concept that I have to tell you first. So you see the solutions are three types: unsaturated, and another is the saturated, and supersaturated. Unsaturated, saturated, and supersaturated solution. In unsaturated solution, you first try to understand the concentration of ion normally less. In unsaturated solution, the ionic product is less than the solubility product. But in saturated solution, the ionic product is equal to solubility product. But in supersaturated solution, the ionic concentration is more. So the ionic product exceeds over the solubility product. You see, when we are calculating the Ksp of AgCl, that is equal to the Ag plus concentration into Cl minus concentration. This concentration, if you take the product of the molar concentration of all the ions, that is the ionic product, and that is the solubility product. The solubility product is experimentally determined. It is not given, it is experimentally determined, or it is experimental data will be given. But ionic product is calculated from the ionic concentration. That is a variable one, but that is constant. It is a constant, but it is variable. So when this is exceed, when the ionic product exceeds over the solubility product, then the precipitation takes place. So with one example, we can understand this concept. Consider question number 5. Ksp of AgCl is 1 into 10 to the power minus 8. 1 into 10 to the power minus 3 molarity of AgCl, AgNO3 mixed with 1 into 10 to the power minus 4 m NaCl solution. Predict equal moles of 1 into 10 to the power minus 3 moles of AgNO3 equal volume, we can say. So the precipitate, predict whether it is precipitated or not. Okay. So you see, what is the concentration of Ag plus ion? Ag plus ion concentration is equal to AgNO3 concentration because it is soluble. So that is equal to 1 into 10 to the power minus 3. The Cl minus concentration is same as the NaCl concentration. that is equal to 1 into 10 to the power minus 4. When the two equal volume, as it is given the equal volume, two equal volume is mixed together, the concentration reduces to half. So it will be the Ag plus concentration after mixing it will be by 2 and Cl minus concentration is equal to by 2. So with this, so the Ksp of AgCl that is equal to Ag plus concentration into Cl minus concentration. Ag plus concentration 10 to the power minus 3 by 2. It is 1 in 10 to the power minus 4 by 2. 1 in 10 to the power minus 4 by 2. If it multiply, it will be 10, it is 1 by 2 and 1 by 2, it is nothing but 0.25 in 10 to the power minus 8. Clear? Now 7. 3 and 4, that is 7. But here the Ksp is given how much? 1 in 10 to the power minus 8. So which is greater? Is it equal or different? So this is nothing but this is the ionic product and this is nothing but this is solubility product. Okay. So the ionic product value is 10 to the power minus 7 and it is 10 to the power minus 8. Which is greater? Minus 7 is greater. So that means the ionic product exceed over the solubility product. So precipitation will takes place. Okay. Now we can see this type of questions. What we are studying here. The solubility product of the AgBr is given 5 into 10 to the power minus 13. So I request to read out the questions. Read the question.
Solubility product of silver bromide is 5 into 10 to the power minus 13. The quantity of potassium bromide molar mass taken as 120 gram mole to be added to 1 gram of 1 liter of 0.05 molar solution of silver nitrate to be added to the volume of 1 liter of 0.05 molar solution of silver nitrate to start the precipitation of AgBr. Okay,
thank you. So now you see the Ksp of AgBr, what is given here. Ksp of AgBr Ksp, how much given? We can write it, note down it. It is the Ksp of AgBr, that is given 5 into 10 to the power minus 13. And a quantity of potassium bromide to be added to the liter of 0.05 m solution of silver nitrate to start precipitation. So here it is not given it is not asking whether it is precipitate or not. It is asking about the what amount of KBr to be added so that it will be precipitated. Are you getting my point? So you see the KBr molecular mass is given the 120 gram per mole. So then the silver nitrate. The Ag silver nitrate concentration, how much it is given? It is given 0.05 m. So to add it to 1 liter, total solution is 1 liter. 0.05 m solution is given. Okay. So the Ksp of AgBr, are you getting my point? Is equal to the Ag plus concentration into Br minus concentration, and Ag plus concentration is nothing but the AgNO3 concentration. The Ag plus concentration is equal to 0.05. Ag plus concentration 0.05. And what about the Br minus concentration? That we have to find out. So the Ksp is given it 5 into 10 to the power minus 3. Now the Br minus concentration you can calculate. So that Br minus concentration is equal to 5 into 10 to the power minus 3 by 0.05. So that will be something around how much it is come? 0.1. So the Br minus concentration is 0.1. So that means the Br minus concentration is nothing but the Kbr concentration, and Kbr concentration is 0.1 m. So if the 0.1 m, so in 1 liter of solution, how much of AgBr to be added? So that is nothing but it will be, how much it will be, looks like. So 1 m, so if you know the molarity of the solution, that is the W into 1000 by the W1 M1 into V milliliter, and for the liter, after 1 liter we can convert to the, so W1 we have to calculate, that is the 1000, molecular mass is 120, molarity is 0.1, and it is 1000. So that will be the W1 is equal to 12 gram only. So does it match there? No. So why it is not matching? Because we have made it is 13. Minus 13, it has to be 10 to the power minus 13. Wrongly we have taken it. So my student is not looking to the question correctly. So that is the problem. So okay, so how much it will be coming here?
10 to the power minus 11.
10 to the power minus 11. Okay. So it will be 10 to the power minus 11. So in place of this we can write 10 to the power minus 11, so that it will be 120, it will be equal to 12 into 10 to the power 12 or 1.2 we can write. It will be, answer will be the W1 will be equal to 120 into 10 to the power minus 11, or in the question is given 1.2 into 10 to the power how much? Minus 9. Okay, that is the answer, and that is matching also. Okay, thank you. Are you getting clear? So this is the another variety of the problem that acts in the solubility products. You clear? I hope my students is clear over this. Okay, thank you.